I'm going to record myself doing a bunch of transformation and translation and whatever problems. I'm going to point you towards this chart that I made that basically describes each type of change that we're looking at with an example. Okay? So that's what I'm going to be referring to a lot. I handed these out in class. I don't know, I think it's on Schoology too. Okay. So there could be a point where I ask you to describe the type of transformation happening for the parent function. So this is just purely recognition. So if I'm looking at number 1, I'm looking at f of x plus 6. So anytime you have f of x and we're adding outside of these parentheses, that means we're looking at something that's like f of x plus k. So here I have f of x plus 3. I'm moving up by 3. This particular example is f of x plus 6. They're not telling us what f of x is. So all I can say is that this is going to be up by 6. They're saying h of x is 0.25 times f of x. When we're multiplying by a factor between 0 and 1 and we're outside of f of x, that is going to be a compression. So it's a times f of x, where a is less than 1, but it's got to be greater than 0. So here we have 1/3 f of x. That's going to be a compression by a factor of 1/3. The example in the notes was by 1/4. So this is going to be compression. Oh, by a factor of 0.25 or 1/4. Okay. Here, j of x is f of the quantity x minus 4. When we're adding or subtracting inside of the parentheses here, when we're inside, that's a horizontal shift. So I'm going to say horizontal. If you look at our reference sheet, that's going to be a horizontal shift to the right because we're subtracting x minus h. So f of x minus 3, we're going to move to the right by 3. F of x, quantity x minus 4, we're going to be moving to the right by 4. And here we're looking at f of negative x. So when the negative is inside the parentheses, what we're looking at is a reflection along the y-axis. Great. You may have a function that involves one more type of transformation of the parent function, and you may be asked to describe that transformation. So if we look at this, we have f of the quantity x plus 2 minus 4. So what this is telling me, just like last time, is we're moving down by 4, so it's a vertical translation. And what this is telling me is that we're moving to the left. I'll go over here. We're moving to the left by 2. So this is going to be down 4 based on this minus 4 outside the parentheses. And because it's x plus 2 inside the parentheses, we're moving to the left. I'm going to refer to the sheet one more time unless we encounter something new. But x plus h is a horizontal translation to the left. So here I have x minus 1, so I'm going to move to the right by 1. And this 0.5 is a compression factor, so it's going to be compressed. Whoops. I don't know what I just did. Oh, it froze up again. This happened in my last video. I got to give it a second. Okay. I'm compressed by a factor of 0.5. Here, because I'm adding outside of the parentheses, I'm going up vertically by 2. And because there's a number we're multiplying f of x by outside of f of x and it's greater than 1, I'm stretching by 3. Okay, and then last one in this section, f of negative x. So when we have a negative x, that's a reflection along the y-axis. And the x plus 3 means I'm moving to the right by 3. I'm sorry, to the left by 3. I'm having a lot of trouble here. Hold on. All right, I think I got it. Whoops. So it was to the left by 3. Okay. So that's just recognizing multiple transformations in one function. Okay. You might be asked to graph certain transformations given a parent function. Did I spell this wrong? I guess not. Okay. So if I have f of x is equal to negative 2x, I might be asked to graph what is f of x plus 1 minus 2. So what I'm going to do is, just a quick way of doing this is I can find a point on my parent function. So this goes through the origin. And then I can, from that point, go to the left by 1, and then down 2. How did I know to do that? This tells me to go left 1. This tells me to go down 2. So I went left 1 and down 2. How do I draw my new function? Well, there's no change to the slope. There's no compression or stretch factor. So I know my slope should remain negative 2. So I just go down 2 over 1. And that's my new function. In addition, you could write the equation for the new function and graph that. Here, I know I'm going to go, let me get a different color. I already have blue. Hold on. Black should be fine then. That's hard to see. Let's go orange. All right. Here, I know I'm going to have to go up 1. And then I'm stretching by a factor of 2. So my slope is going to increase or be multiplied by 2. So instead of a slope of 2, I'm going to have a slope of negative 4. So I can go down 4, 1, 2, 3, 4, over 1. And that's my new function. So this is going to be h of x. The other thing we can do is we can figure out the equation of our new function. So if I had, did I freeze again? Here we go. F of x is negative 2x. Then I can do f of x plus 1. Whoops. So I can say g of x, because that's what my function is here. G of x is equal to negative 2 x plus 1 minus 2. We can distribute that negative 2 and say negative 2x minus 2 minus 2, which would be negative 2x minus 4. So that's g of x. This is written in the form of y equals mx plus b. So I know I'm graphing a line with a y-intercept of negative 4. And so you can see that my y-intercept is at negative 1, 2, 3, 4, and it has a slope of negative 2. We could use the same strategy over here. Okay. You might be given a function and asked to transform it in specific ways. So if f of x is equal to 0.5x minus 1, then I might be asked to write the equation for g of x, which is a translation of f of x up by 2 and stretched by a factor of 2. Okay, so I always write g of x in terms of f of x and then plug it back in. So g of x is equal to f of x. If I have to move it up 2, I add 2 outside the parentheses. And if I have to stretch vertically by a factor of 2, then I put that 2 outside of the f of x. Okay, and you can refer to that chart that I was telling you about at the beginning to really see those. Now I'm going to take what f of x equals and plug it in here. So g of x is equal to 2 times 0.5x minus 1 plus 2. I'm going to distribute this 2. So 2 times 1/2 is equal to 1. And it's x, so I don't even need that 1 there, but we can leave it. 2 times negative 1 is negative 2. So x minus 2 plus 2. I can combine like terms. So negative 2 plus 2 is 0. So g of x ends up just being x. Here's another example. So they want the equation for h of x, which is f of x compressed by a factor of 0.5 and moved to the right by 3 units. I'm going to write h of x in terms of f of x. So moving to the right, I would have to subtract by 3 inside the parentheses. Again, you can refer to that chart I gave you at the beginning to see where that came from. And to compress by a factor of 0.5, I would have 0.5 outside and multiply f of x by that. Now I can take this all and plug in my original f of x. So h of x is equal to 0.5 times 0.5. Instead of x, I'm going to put in x minus 3. And then minus 1. Okay, we're going to deal with these parentheses one at a time, and we're going to do the inner ones first. So 0.5 times x is 0.5x. 0.5 times negative 3 is negative 1.5. And then we have our minus 1 still, and we multiply all that by 0.5. I'm going to combine like terms here. So let's move up. I get 0.5 times 0.5x minus 2.5. That came from negative 1.5 minus 1 is negative 2.5. And then I'm going to distribute my 0.5. So 1/2 times 1/2 is 1/4, which is the same as 0.25x. And then 1/2 of negative 2.5 is negative 1.25. So that's h of x. So that one, the arithmetic is a little bit annoying, but overall, you're compressing by a factor of 0.5 and moving it to the right by 3 units. Okay, so that's a bunch of example problems using the chart that I gave you to kind of figure out what that translation would look like. A lot of it has to do with recognition, and some of it has to do with actually applying those translations to different equations.